Good afternoon, everyone. So today's topic is arithmetic progression and geometric progression. So shortly we call it as APGP, arithmetic progression. So for the first half of the session, we'll introduce arithmetic progression, and in second half we'll introduce the geometric progression. If time permits, then we'll do the proofs of formula. Otherwise, I'll just give formula wherever needed or whenever needed, but without proof for today. Yeah, so shortly this is called as AP and it's called as GP. So let's start with a story, and it's a story of great mathematician Carl Friedrich Gauss. So he was a German mathematician from Germany, and his period is 1777 to 1855. So almost 240, 250 years back. And he was a child prodigy. Right from his early days, he showed great abilities of mathematics. So there is a story that when he was 3 years old, he found a mistake in his father's accounts. So this is all well documented. It's a true story. He found a mistake in his father's account. Can you imagine at the age of 3 years what maths we used to do? And he found mistake, not just added all those numbers, but he found a mistake in his father's accounts. So he was a child prodigy, very fast right from his early school days. I'm going to tell you a story when he was 6 years old, maybe in first standard or second standard. Story when he was 6 years old. The story is as follows. So once their teacher gave a long sum for addition, 1 plus 2 plus 3 plus 4 and so on up to 100. Add all numbers right from 1 up to 100. And teacher thought that perhaps students will take about 30 minutes and maybe then you can take a rest for some time. But surprisingly, Gauss did in a nice, fantastic manner. And what Gauss did was following. So he took the sum as follows. So Gauss technique was following. The numbers are very well structured. So they are all with a difference of 1.
Is it 5050?
Very good. Yeah. Yeah. So Gauss technique was following. Add first and the last number. That is 101. Then what will be number before 100? That will be 99, right? Okay. So add second number and the second last number. And this sum is again 101. Then add third number and third last number. And again,
I did like this. I did the same method.
Oh, very good. So essentially what you see, the numbers are so structured that when you go one place up here and one place down here, here it's one more, there it is one less, so that the sum turns out to be same for all numbers, all pairs, right? And total numbers are 100 in number, total numbers. So how many pairs are there? How many pairs are there?
50, sir.
Yeah, all of you agree? All of you
50.
agree? 100 by 2. There are 50
sir.
pairs.
50.
All of you agree? There are 50 pairs. And each pair gives us sum equal to 101. So the total sum would be total sum
101 would into 50.
101,
5050.
101. How many times? 50 times. And as we know, repeated addition is essentially multiplication. So this is 101 into 50. 0505. The answer was 5050. Okay, so that's the story of Gauss. So when he was 6 years old, and teacher could not rest as expected. Yes, Rutvij, very good. Yeah. Okay, so this is example of what is called as arithmetic progression, and this is obvious example, but later on we'll see more examples and little better structure of arithmetic progression. But essentially, what's the idea here? The difference between first two terms and the difference between last two terms turns out to be same. Then here again 2 to 3, it's one more. Here 99 to 98, it's one less. Right? So whatever
It is similar to factorial, but instead of multiplication, we take the addition.
yes, very good. Yeah. And then with this Gauss idea, we can have a general formula. Now let me try to derive the general formula. Anyway, let me tell you something more about Gauss. So, as I said, he was very fast, and right from his early childhood, he showed great ability towards mathematics. So, at the age of 19, he did his master's. When he was 19 years old, did his master's. So, whatever MSc, MA, whatever degree that time. And at the age of 22 years, he completed his PhD. So I hope all of you know what is PhD. So generally, let me tell you the ages we require here nowadays to complete our master's and PhD. So for example, I passed my bachelor's degree at the age of 20 years. So what are BSc, BTech, BE, whatever. So you complete your bachelor's at the age of 20. Then 2 more years, you complete your master's. If you don't fail in any exams. And after your master's, you do your PhD. And nowadays, if you want to do some good PhD, you need at least 2-3 years of reading, and then further 2-3 years of sincere work, hard work to get some results in mathematics. So at least you need about 5 years for PhD. So by the time you get your PhD, you are 27 years old, at least 27 years. So PhD is doctorate. So after this, you can write your name as Dr. something. So he got his PhD at the age of 22 years. Right? So he was at least 5 years faster than all of us. And rightly, he was said as Prince of Mathematics. So it's called as Prince of Mathematics. And he worked in many areas. Like for example, he worked in number theory, congruence, etc. is all his original work. Then he worked also in algebra. In fact, his PhD thesis was in algebra. that is fundamental theorem of algebra. Then he worked a little bit in physics, and towards the end of his life, he worked in astronomy, not astrology, this is astronomy. So he was the chief of Göttingen Observatory in Germany. Also, he worked in complex analysis, which was comparatively new subject at that time. In fact, Pascal started some serious study of complex analysis. Afterwards, Euler studied, and after Euler, Gauss studied complex analysis. Then Gauss had some fundamental work in geometry, particularly non-Euclidean geometry. What is Euclidean geometry? One which we learn in schools is due to Euclid, or it's from the Euclid's book Elements, which is in 13 parts, and something different from the standard geometry, Euclidean geometry, is called as non-Euclidean geometry. In fact, such non-Euclidean geometry was used in Einstein's theory of relativity. So something which is useful or which has some great applications that survives, or people study those things. So even after Euclid geometry, why people studied something non-Euclidean? Because that has got applications. Yeah, so that is something about Gauss work and his speed or the fastness. In fact, he wrote a book on algebra number theory at the age of 24 years. So when he was 24, he wrote a book. The language was Latin at that time. Now even English translation is available. So I don't know how to pronounce it, but I'll write the name. Disquisitions Arithmetica. So that is investigations into arithmetic, that is algebra number theory. That's the meaning of Disquisitions Arithmetica. It's a Latin name, and it's all his original work. It's not taken from some other earlier books, etc. So all things were new, all concepts were new, his original concepts. And particularly, if you have heard of congruence notation in number theory, congruence, etc., was introduced by Gauss in this book. So that's a classic and very legendary book. Which changed, in fact, the course of number theory. Yeah, so let me again go back to first page, what we're talking. Yeah, so this is Gauss technique. Some of you have joined little late. This is Gauss technique to add 1 to 100, and this he used at the age of 6 years. So probably when he was in first or second standard. Okay, of course, this formula or this technique was known to Indians, Chinese. In fact, Aryabhatta's book, Aryabhatiya, it contains formula for addition of 1 to n, addition of 1 square, 2 square up to n square, addition of 1 cube, 2 cube up to n cube. So Aryabhatta knew the formula for these sums. So it's not that Gauss was the first one to invent these things. Only thing, the nice part is, at the age of 6, he used all these things on his own. Obviously, at the age of 6, he might not have read something like Aryabhatiya or any Chinese book. So that was his original idea. Yeah. So now let's devise general formula for 1 to n.
I had also like seen like I had tried to add these numbers like 3 or 4 years ago, and I also come up with the same formula.
Yeah, that's very good. That's very good. Okay, so now we want to derive or devise a formula for sums of this form. So this formula will be used later, and therefore I need this. What is the sum? 1 plus 2 plus 3 plus so on up to n. So one idea is following. I'll show in a little imprecise manner. The Gauss technique, add first and the last. And what is that? N plus 1. Then add second number and the second last. Can you say what will be number before n? What should I write
N
for?
minus 1. N
Yes,
minus 1.
so 1 less to n. All of you agree?
Yeah.
N minus 1. And what is 2 plus n minus 1? So it's n plus 1. It's 2 minus 1. That is plus 1. Fine. So
Yeah.
first number plus the last number is n plus 1. Second number plus second last number is n plus 1. So all such pairs give us addition n plus 1, n plus 1. And total numbers of total numbers are n. And for the timing, let's assume n is even. Like for example, Gauss was given 1 to 100. And if it is 1 to 100, how many pairs are there? Those?
N plus 1 into half n.
Yeah. So if it's 1 to 100, there are 100 by 2 pairs. And for the timing, let's assume the case where n is even. Even if n is odd, we can manage the same thing. But for the timing, let me
Yeah.
show. So we get answers n plus 1, n plus 1, n plus 1. How many times? N plus 1, n plus 1, n plus 1. How many times? Essentially n by 2 times, right? For 100 you said answer is 50 pairs. So similarly, assuming that n is even, this answer is n by 2 times, right? So what we get is this answer turns out to be n plus 1, n plus 1, n by 2 times, and that is multiplication. So it's n into n plus 1 divided by 2. And that is the formula. Yeah. Hope you got it? Any doubt, any question, any query?
Sir,
Yes,
n can be any number, right?
yes. Yeah, but even if n is odd, we can manage that. And let me show you a technique where
Can
Well,
I
doesn't matter whether n is odd or even. In fact, we'll use following technique. So let me call this sum as s. So let s is equal to 1 plus 2 plus 3 plus so on up to n minus 1 plus n. And also, now do you agree that if I'm writing or taking some 1 plus 2 plus 3 plus 4 plus 5, I can also say this is same as 5 plus 4 plus 3 plus 2 plus 1. Is it right? Are they same?
Yes.
Yes,
Yeah.
sir.
So this property is called as commutativity of addition. Commutative. Like for example, if I take say 4 minus 2, that is not same as 2 minus 4. So subtraction is not commutative, or 4 divided by 2 is not same as 2 divided by 4. So division is not commutative, but 4 into 2 is same as 2 into 4. So multiplication is commutative, right? So addition and multiplication are commutative operations, and therefore I can write the same thing in reverse fashion, reverse order. Is that right? Yeah.
Thank you, sir.
Yeah, so I'll write same thing as s equal to, I'm going to write it in exactly opposite order. So first number will be this last one, n Then what will be next number? N minus 1.
N minus 1.
Now I'm coming down from n to 1, right? Then next will be n minus 2 and so on up to lastly 2 and 1. So far good? And
Yes, sir.
now I'll add vertically. So I'll add two equations. On left hand side, what do I get? That whatever number s, whatever answer, we don't know. So suppose s plus s, what shall I call it? 2s. I hope all of you know these equations. Very first day while solving puzzles, you said x plus x is 2x. So on same lines, s plus s is 2s. Everyone agrees?
Yes,
Yes.
sir.
Yeah. So on one side I get 2s, and now I'll add this way. This plus this, 1 plus n, 2 plus n minus 1, 3 plus n minus 2, n minus 1 plus 2, n plus 1. And see that every answer is basically n plus 1, n plus 1, n plus 1, right? Each such pair gives me answer n plus 1. Everyone is convinced? And how many times I get n plus 1? How many times?
N
1,
n
3,
times.
4, so on up to n times. So I get
N times.
n plus 1, n plus 1, n plus 1, n times. Yes, Ruti.
So I have a doubt. How do you get n plus 1 n times? Because, for example, if we are from 1 to 100, then we get 50 pesos. So,
Okay. I'll explain with the help of small example, and you try to get convinced. See, suppose for example, suppose I have s equal to 1 plus 2 plus 3 plus 4 plus 5. Okay, and I write same thing as 5 plus 4 plus 3 plus 2 plus 1, right? So I add s plus s to s is equal to 5 plus 1, that is 6, 4 plus 2, that is 6, 3 plus 3, that is 6, 4 plus 2, that is 6, 5 plus 1, that is 6. And how many times I get? 1, 2, 3, 4, 5. So I get 6, 6, 6, 5 times. Right? So on same lines, I'll get n plus 1, n plus 1, n plus 1. How many times? N times.
okay.
Now I'm not taking pairs like first and last, second, last. I'm not taking pairs. Once you take pairs, it becomes half. But now I'm taking direct addition of n numbers. Are you convinced?
Yes, sir. Thank you, sir.
Okay, so I hope everyone is following.
Yes, sir.
Yes, sir.
So 2 times s is equal to. Now, when I said, say for example, 101, 101, 101, added 50 times.
Sir?
Yes.
So why do you put 2s?
Because I'm adding these two, s plus s.
Okay, thank you.
Yeah. So I want to talk about that sum on right hand side. Say n plus 1 added n times, and just try to understand with the help of example. Suppose we want to say 101, 101, 50 times. What did we say? That is same as 101 into 50.
100,
All of you agree? So similarly, shall I?
100 times, right?
No. Suppose for example. Suppose I want to, I'm adding 101, 101, 101. Suppose I'm adding 50 times. What shall I say? That is same as 101 into 50, right? So on same line, shall I say this is n plus 1 into n? Or multiplication is commutative. So shall I say this is same as n into n plus 1?
Yes, sir.
Everyone is convinced?
Yes, sir.
Yeah. So 2 times s So 2 times S is equal to n into n plus 1. When I put bracket, it's multiplication. I'm not writing that sign into sign cross, because many times when you use variables, that cross is confused with X.
We can also write this in a shorter version, right? N square plus n.
Yeah, yes. So 2 times S is n plus 1. Now suppose, for example, if I say 2 times S is 100, how much is S?
50.
50. 100 divided by 2.
So how did you get that? 100 by 2, right? So on same lines, 2 times S is n plus 1. So what shall I say? S is equal to n into n plus 1 divided by 2,
2.
right? So we have proved that Gauss formula. In fact, essentially it's not Gauss formula. It was earlier derived by, or it was known to Indian mathematicians like Aryabhatta, Bhaskaracharya, Brahmagupta, or even some Chinese mathematicians. Yeah. So far good?
Yes, sir.
Yes.
Now, based on this formula, or maybe using Gauss technique first, last, second, last, and so on, try to find out some simple sums. So let's do some simple examples, not typically Olympiad type. Can I go to next page?
Yes.
Yes, sir.
As usual, you can write answers in chat box, but only to me. Don't disclose the answers, or even don't orally tell the answers. You can write down in chat box as usual. To me, some simple examples. Either use formula or Chota-Gauss technique, or what are your own technique? Yeah, so first one, as I said, don't hurry up. Olympiad is not some race like I am first, you are second. So it's more about thinking and understanding the techniques. 1 plus 2 plus 3 plus 1 up to 19, 20. Plus 4 plus 6 plus 8 plus 1 up to 18 plus 20. Yes, something interesting.
Yes.
Some of odd numbers, and that is nice pattern. 1 plus 3 plus 5 plus 1 up to say 21. More interesting sum. I'm not giving from 1, 51, 52, 53, 54 up to 100. Okay, I'll give you some time. Maybe shall I give one more? Simple one. 5 plus 10 plus 15 plus 20, so on up to 9500. So gradually we are going towards actual examples of AP, arithmetic progression. Shivansh, check that third one. That will be some square number. Shivansh, I think there is a typing mistake. Still, it's not a square. 131 is not a square. Yeah. So what are you using? Formula or Gauss technique or some other way, your own way?
So I'm using Gauss technique, sir.
Okay.
Sir, I'm also using Gauss.
Sir, I'm using both.
Oh, okay. Shivansh, good, very good. Yeah. So shall I start discussing the solutions? I mean the answers.
Okay.
So the first one would be 210.
So how did you do that?
Sir, I added 20 and 1 and then I
Just a minute.
divided
Just a
20
minute.
by
Just a minute.
2.
Take a minute. So I'm writing the question again. 1 plus 2 plus 3 plus so on up to 18, 19, 20.
Sir, is my first and second answer correct?
Yeah. And if you are using Gauss technique, what you'll be doing is following 1 plus 20, 21, 2 plus 19, 21, 3 plus 18, 21. Please note, when can we use Gauss technique? If all sums turn out to be same, right? And generally this happens when the differences are equal. And when differences are equal, such a sequence is called as arithmetic progression. Okay, so we get 21, 21, 21. And how many times? There are 10 pairs, right? Total 20 numbers. So there are 10 pairs. So it's 21 into 10.
What is the sequence called?
Arithmetic progression. That is what we are learning today.
Okay. Okay.
But so far I haven't started with the actual definition. This is special case. This is special example.
Sir,
Yes.
doubt. So how do we find out 21 is like repeated 10 times?
So why 10 times? Because total numbers are 20. Right? Total numbers are 20. And I'm taking pair. First, last. Second, second last. Third, third last. So if I write pairs, how many pairs should be there? There should be 10 pairs, because once there are 10 pairs, there will be 10 into 220 numbers, right?
Yes, sir.
So number of pairs is always this number divided by 2,
Okay, sir. Thank you, sir.
right? Yeah. So that is 200.
200.
Okay. Another way, if I want to use,
Sir, in some odd numbers, we have to divide the like, sum of the first and last number 2, and then we have to add that add that number plus the number into what the time.
yes. So we'll use now formula. Once again, what is the formula? 1 plus 2 plus 3 plus so on up to n is equal to n into n plus 1 divided by 2. And in this case, in this problem, n is how much? The last number, that is 20. So you put n equal to 20 in the formula, right? So your answer is 20 into 20 plus 1, 21 divided by 2. I hope you know how to simplify these things. 2 1s are 2, 2 10s are 20, and then 21 into 10, that is 210.
Sir, can you please show the previous question?
Yes,
screen?
yes. So everyone followed this?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Yeah, somebody wanted this page to check the problems.
Yes, sir. Thank you.
Yeah. So let's go to second. 2 plus 4 plus 6 plus 1 up to 20. Two plus 4 plus 6 plus so on up to 18, 20. And now what are these numbers? These are all even numbers, right? And you see all even numbers, they are with a common difference of 2, right? Such a sequence is called as arithmetic progression. So like we have some first number, then second number is a plus whatever common difference. Like for example, for even numbers difference is 2, for odd number again difference is 2, right? Only thing, even start with 2, odd start with 1, and I write terms with a difference of 2. So 1 plus 2 3, 3 plus 2 5, 5 plus 2 7, 7 plus 2 9 plus 2 11 plus 2 13, and so on. 2 plus 2 4 plus 2 6 plus 2 8 plus 2 10 plus 2 12, and so on. Right? So such a sequence is called as arithmetic progression. Yeah, so we are adding terms of arithmetic progression. Okay, and later on we'll derive formula even for sum of arithmetic progression. But for now, yeah, so what techniques you are using? Either Gauss or, for example, do you know we can take 2 common from all terms because they are all even numbers. So they are multiples of 2. 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 9s are 18, 2 10s are 20. And I can use formula for this. Right? So that is one technique. So 2 into what is by formula 10 into 10 plus 1, 11 divided by 2. 1 plus 2 plus so on up to n is n into n plus 1 divided by 2. So it's 10 into 10 plus 1, 11 divided by 2. Then these two cancel. And 10 into 11 is 110. So answer is 110. I guess most of you have got it correct. Right? So this is one technique. Can somebody tell me some other way?
Sir, can I tell?
Yes.
Sir, we can do it by the number of terms upon 2 multiplied by first term plus last term.
Number of
Number of terms divided by 2 multiplied by first term plus last term.
right. So first and the last. That is 22. Second and the second last. That is again 22. Third and the third last will be 22. Right? So we get 22, 22, 22. And how many times? These are how many numbers? So how that will give us how many pairs? Out of first 1 to 20 numbers, do you agree that 10 will be even and 10 will be odd? And we are talking of even numbers. So these are 10 numbers, or you can count actually 2, 4, 6, 8, 10, and so on. You can count actually 10 numbers. So everyone agrees these are 10 numbers. Everyone agrees these are 10 numbers.
Yes, sir.
And 10 numbers
Yeah.
means 10 numbers means how many pairs?
5.
5 pairs.
Very good.
5 pairs.
5 pairs.
Very good. So, as Rutuj was saying, it's 22 into 5, right?
110.
Any other technique? Anybody has used some different technique?
Sir,
Hmm?
multiply first, add first term to last term.
Hmm?
No, wait.
That is same. So this.
Yeah, that.
So shall we go then for third one?
Yes, sir.
Yes, sir.
1 plus 3 plus 5 plus so on up to 21. Yeah. This is something interesting. And you see there is a nice pattern. In maths, in fact, patterns are important. And just with pattern, many times you can guess the answer. So 1 plus 3 is 4. 1 plus 3 plus 5 is 9. And you see what are these numbers? 1, 4, 9. They're square numbers, as somebody told last time. So shall I say this is 1 square, this is 2 square, this is 3 square. So sum of first 3 odd numbers is 3 square. Sum of first 2 odd numbers is 2 square. More generally, what should I guess?
Also we can see that like in this like 1 plus 3 plus 5, so 5 minus like 2, and like the first one is there, and the second one like 1 plus 3 the last number minus 1. And the third one, number minus 2. Like
Right, right.
becoming
So,
2.
yes, yes. So shall I say more generally, sum of first n odd numbers? This sum is equal to how much? N square. Can I say that? Is it correct statement?
Yes, sir.
Yeah. Now, with this observation, answer 1 plus 3 plus 5, so on up to 21. How many are these numbers? How many odd numbers? How many? You can actually count, or we saw that up to 20 there were 10 odd numbers, 10 even numbers, and 21 is one more. So these are 11 odd numbers, right? Is that right?
Sir,
Yes.
how did you find all the odd numbers in this third problem?
So question is, how many odd numbers are these? You can actually count, like you can write down, because they are less in number, you can write down and you can count. That is one simplest way. But if in general, if numbers are more, then you should have some tricks to use to find out the number of odd numbers. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this last is 11. Now, what I'm saying is up to 20, up to 20. Half will be even and half will be odd. Do you agree?
Yes, sir.
So there will be 10 odd and 10 even up to 20. So as you can see here, 10 odd. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 odd up to 20 and one more about 20. So there are 11 odd numbers.
Okay, sir. Thank you, sir.
And sum of first 11 odd numbers will be how much? 11 square. How much is 11 square? 121. Okay.
Thanks, sir.
Or else you can use some trick like this. So I'll go to next page. Because already I know something about 2 to 20, so I can use that fact. So 1 plus 3 plus 5 plus 7 plus so on up to 19 plus 21. And always you can use some known answers to find some new answers.
We can also solve this like 22 6 like 22 5s are plus 11.
Right, right. So yeah, so that's what I'm going to say. So 1 plus. Now this 3 I'll split as 1 plus 2. Okay, agree? 5 I'll split as 1 plus 4. 7 I'll split as 1 plus 6. And so on. 19 I'll split as 1 plus 18. And 21 I'll split as 1 plus 20. All of you agree with this addition?
Yes, sir.
Yes, sir.
Yeah. Now, this 2 to 20 we have already worked. This is known to us. This is known or already worked. Okay. What does that answer? 2 to 20? That is 110. 110, right? And plus this 111, how many times you get? There are 11 numbers. Of course, this counting should be precise. Otherwise, you'll get some wrong answer. So how many numbers are these? These are 11 numbers. All of you agree?
Yes, sir.
So I'll say 111 11 times, that is 11. and therefore total it is 121. Right?
Okay, sir.
Yeah. By the way, there is some nice geometry involved with these numbers, like how we get squares. Just let's try to see. 1. Look at some nice geometrical patterns. 1 plus 3. I'm adding 3. 1, 2, 3. And you see it's again a square. Right? Plus 5. 1, 2, 3, 4, 5. In fact, when I was of your age, that time there were not so many channels, and there was one Australian channel for cricket. It was some channel 9 or something, and they had this symbol. There were 9 dots. Yeah. So 1. So 1 plus 1 plus 3 plus 5 plus 7. 1, 2, 3, 4, 5, 6, 7. And see that all these additions essentially give us squares, right? So these are all square numbers. Answers are square numbers. Similarly, if you add 1 plus 2, that is Gauss sum, plus 3, plus 4, they are all numbers which we can represent as triangle. So they are called as triangular numbers. What are triangular numbers? 1, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, and so on. Now, just as a curiosity or as exploration, at home you can try what are pentagonal numbers, what are hexagonal numbers. Try to find out such sequences. Everything starts with 1. And then you can get general formula for all such numbers. Yeah. Shall we go for fourth one? Yeah, सब लोग सो गए क्या? Shall we go ahead? Am I audible? Yeah.
Yes, sir.
Yeah. So let's
Yes,
go.
sir.
Is this something interesting? I hope this is not too tough.
Yes.
Yes, sir.
Just a minute. I'll go back to problem 6. Problem 4. Oh, 51 to 100. (51 to 100). Again, I can use that typical Gauss technique. So first of all, these are how many numbers? 50, right? And therefore, if I make pairs, how many pairs will be there?
25.
25.
25.
Pairs. And each pair will give me what sum?
151.
151.
52 plus 99. And you can see that all that's also same as 151 because 52 is one more than 51 and 99 is one less than 100. So I add one, subtract one, and therefore essentially the sum is same. So what is the answer? 151, 151, 151, 25 times. 25 एक 25 अचले 2 25 पचा 25 असे 125 ने 2 127 अचले 12 25 एक 25 ने 12 ना करे 375.
Sir,
Yes. Yes. Am I audible?
Yes.
I gave the answer. I didn't.
So is this answer correct?
Yes, sir.
Yes, sir.
Yeah. So those who have written
Yes.
answers, you can check the answer. Now let me show you one more technique which is common and frequently used in typically Olympiad type problems. So 51 to 100. I know formula for 1 plus 2 plus 1 up to n, whereas this starts with 51. And I want to use suppose this formula. What I'll do is add 1, 2, 3, 4, so on up to 50 and again subtract it. So do you see, suppose if you give me some 50 rupees and take it back, answer will be same with me or money with me will be same. So I'm adding 1 plus 2 plus 1 up to 50 just for the formula purpose and subtract 1 plus 2 plus 50. Is it okay?
Yes.
So I get two sums. First is 1 to 100, and I know that answer is 100 into 100 plus 1, 101 divided by 2 minus. Now this sum is 1 to 50. Is this technique clear to everyone? Add 1 to 50, subtract 1 to 50. जितना दे उतना वापस लो. As simple as that. Right? Minus 50
So it is
into 50.
it is like if I don't have a 50 rupee note, I will give someone 100 rupee note and he will give me change 50.
Yes. So essentially money is same, right?
Yes.
So this is 100 into 101 minus 50 into 51 divided by 2. Now you find out what are these sums and check that this answer is again same, 3775. Now that I leave it to you. Move ahead.
Yes, sir.
Yeah. Okay, fifth one. So you see, one way they are all multiples of pi, and you can take 5 common and use the formula for 1 plus 2 plus 3 plus 1 up to 20, or you can use Gauss technique 105, 105, 105, 10 times, right?
Okay, sir.
So let's work precisely and write down the answers. 5 plus 10 plus 15 plus 20 up to 9500. So very first thing, that is always important. How many terms are these? How many? Yes, Iqbal.
20. Because 5 into 20 is 100.
Yeah, everyone agrees there are 20 terms, right? Yeah, correct. So if I want to make pairs like Gauss technique, how many pairs will be there? 20 numbers. Make how many pairs?
10.
10. And each pair will give me what sum? 100. And why?
10. 105.
Why? Check. So answer is 105 into 10. I saw some time back many answers were there with the last answer as 1050. So answers are correct. Yeah, so that is one way. Or another way is take 5 common. बोलो ब्रैकेट के अंदर क्या लिखूं? 5 कॉमन, 1 प्लस 2 प्लस 3 प्लस अप टू 19 5 are 95, 25 are 100, right? Is that right?
Yes.
Yeah, and now I can use formula for this. So it's 20 into 21 divided by 2. So 2 1s are 2, 2 10s are 20. So it's 210 into 5. अच्छा के पास होने का 1050. So I hope this idea of Gauss technique and how to take sums when the numbers are with equal differences is clear to everyone. Now let's go ahead to the actual definition of arithmetic progression and the formula for the sum. Go ahead. Of course, so far we have whatever we have done, there are special cases of arithmetic progression. So we are not doing something new. Okay, so let's look at some real life examples. Suppose, so those which are with same difference, common difference. Okay, suppose 4th April was Tuesday. Yeah, it's really Tuesday. Yeah, 4th April was Tuesday. What will be the next Tuesday?
13th April. No. 11th April. 11th April.
11th April.
11th April.
11th. What will be next Tuesday?
18th April.
18th April.
18th April.
What will be next Tuesday?
25th April.
25th April.
Yeah, so you see that if I want same day, they are with a difference of 7, right? Because week has 7 days. So it's cyclic. After 7 days, again you get same day. 4 plus 7, 11, 11 plus 7, 18, 18 plus 7, 25. Or more generally, you start with some number A, then keep on adding same number for every term. So A plus D. Next is this number plus D again. A plus D plus D. So that is A plus 2D. Then A plus 2D plus D. that is a plus 3d. Okay, so my sequence is of the form a plus d, a plus 2d, a plus 3d, and so on. This is such a sequence is called as arithmetic progression. And do you see sequence of even numbers or odd numbers is also AP. So like my first term is 2 and difference is 2. Difference is 2, so 2 to the 4. Difference is 2, so 2 3 the 6. Difference is 2, so
2 plus 8, sir. After 2 plus 6.
So sequence of even numbers is AP. Sequence of odd numbers is AP. Only thing, difference is same. Only thing, first term is different. So even and odd terms form AP. Okay, now let's see some examples, simple examples, and you have to tell me what is the difference, what is the first term. So some simple examples of AP. So find missing terms. First, 1, 3, 5, 7, missing. You can write down in chat box. Don't disclose the answer. Somebody has asked question, arithmetic is it same as mathematics? No. Arithmetic essentially stands for number theory or basic algebra.
Yes, I seen the answer. Snehal.
Right.
Is that
Yes,
correct?
yes. Yeah, everyone has written correct.
I have sent the answer.
Yeah. Problems are simple, so everyone should get. Okay, and now you have to justify why you have written those two terms or why you have written that answer. I'll write down answer here, which is given by many students. So this first term they have written as 9. This term they have written as 11. Yes, Sripal?
It is so because like there is the difference of 2 in all numbers. So if
Yeah.
1 is a, then a plus 2, then a plus like 2, so there is 4, then a plus 6. So then we have to add a plus 8, that is 1 plus 8, 9, and then 1 plus 10, 11.
Yeah, so everyone
They are odd
difference-
number patterns.
Yes.
Sir, is the term to term rule times 2 minus 1?
Yeah. Or you look at any two consecutive terms, the difference turns out to be same. Like 3 minus 1 is same as 5 minus 3. That is same as 7 minus 5. That is same as what are blank space question mark minus 7. And that will give you answer. So question mark minus 7 should be 2. And that means question mark should be 9. Right? Okay, so everyone agrees with 9 and 11? Nobody has any different answer?
No, sir.
No.
No, sir.
Fine. So now this is example of AP. What is first term And generally first term is denoted by A, that is 1. And what is difference, common difference? Generally that is denoted by D. What is difference? क्या हुआ?
Subtraction.
Yeah. The difference is 2, right? Difference between 3 and 1, 2. Difference between 5 and 3, 2. 7 and 5, 2. 9 and 7, 2. 11 and 9, 2. Okay, so with this A and D, see that first term is A, second term is A plus D, third term is A plus 2D, fourth term is A plus 3D, fifth term is A plus 4D, and so on. So if I ask you in this sequence, what will be 100 term? What will be 100 term? What will be your answer? Observe this
A
pattern.
plus
A plus A plus
A plus
99.
Yeah, very
A
good.
plus 99D.
A plus 99D.
A
plus
plus
89D.
A plus 99D. All of you agree?
Yes.
Yes, sir.
Why 99? Because you see the pattern here. For 2, it's A plus D. For 3, it is A plus 2D. For 4, it is A plus 3D, one less. For 5, it is A plus 4D. For 100, it is A plus 99, one less. 99. And which means it is 1 plus 99 into 2. That is 199.
100.
Oh, have I done wrong? Is that 199?
yes, sir.
Yes, sir.
So I hope this first example is clear. And in general, with same formula, suppose I say Tn stands for nth term of AP with first term A and difference D. What is the general formula? Just now you said the formula for 100, and now I want general formula for n term. So 100 term you said is A plus 99D. That was correct. Now what will be in general nth term? A plus
A plus N minus 1 into D.
n minus 1. Okay, all of you agree?
Yes, sir.
Yes, sir.
And now we are running a little short of time. So without proof, I am giving formula for sum of first n terms. So let Sn is equal to T1 plus T2 plus Tn. But you can use Gauss technique, and with patience you can try to work later on at home and check the formula. So this, when I add T1, T2, Tn together, essentially it is n times A plus n into n minus 1 by 2 times T. That is formula for Sn. Sn stands for sum of first n terms. Okay. Now let's use this for odd sequence, and let's see how we get squares. Fine. सब लोग रेडी है?
Yes, sir.
Yes, sir.
Yeah. So for odd, first term is 1 and difference is 2. And I want to find sum of n terms. So very first thing, what will be nth odd number? And now we have formula for nth odd. So the formula for n term is a plus n minus 1 times t. That is what you have said. So that is 1 plus n minus 1 times 2. That is 1 plus 2n minus 2. And if I collect them together, it's 2n minus 1. All of you agree? So nth odd number is given by 2n minus 1. And now what I want is following: 1 plus 3 plus 5 plus so on up to 2n minus 1. And we saw that sum of first n odd numbers, we saw a nice pattern. It turns out to be n squared. 1 plus 3 is 2 squared. 1 plus 3 plus 5, sum of 3 odd numbers is 3 squared. Sum of 10 odd numbers is 10 squared. Sum of n odd numbers is n squared, right? So let's see by formula. So I want this, and that is Sn. So what is formula for Sn? Na plus n into n minus 1 d by 2. Just a minute. Just a minute. Yeah, so Sn is Na plus n minus 1 d by 2. That is the formula. Of course, I haven't proved because of less time. So we haven't proved. I have given formula. Of course, you can check and verify that formula is really Na plus n minus 1 by 2 times d. So let me put the values. A equal to 1. So that is n into 1 plus n into n minus 1 times d is 2 upon 2. So this is n plus 2 cancels, n into n square minus n into 1 n. So that is equal to n square. Okay, agree? Is that great? Is that fine? Am I audible?
Yes.
क्या रे सब लोग थक गए क्या?
No, sir.
Yeah, so let me give some problems for practice at home and we'll stop them for today. So we have the completed AP. We have completed AP, but we haven't completed GP today. I'll continue with GP tomorrow. That is a little more interesting than this. So problems for practice. And copy down quickly. What is 101st term of AP? First of all, check whether whatever I'm writing is AP, and then you have to find 101st term. So that is T101, n equal to 101. So first term is 4, second term is 10, third is 16, fourth is 22, and so on. Is it AP? Is it AP?
Yes, sir.
Yes, sir.
A equal to first
4.
term
4,
and difference.
6.
We can use formula for 101st term, and you can find out the answer. Find missing term. Find missing terms. 4, 9, 14, 19, missing. Find out missing terms. One more. 88 missing. 112 missing. 136, 148. It's given that these are AP. So you have to find missing terms.
Sir, the
Third one.
formula
Huh?
the formula for the first one is NA plus N minus
Tn is nth term and Sn is sum of n terms. So here for first problem we only want 101st term. So it's A plus n minus 1t, and n is 101. It's 4 plus, this is simple 100 times 6. So the term is 604. Yeah. One more. Missing 215. Missing 620, 755. If you finish writing questions here, I'll go to next page and give one more. Shall I go ahead?
Yes, sir.
First term of an AP is 3. The last term we don't know how many terms are there. It's just given that last term. We have to find which term it is. The 10th or whatever. We have to find out. Last term is 39. and sum of all terms. Sum of all terms is 210. Find the common difference and the number of terms. Then I give one puzzle, but that is little tough. It's based on same ideas. Yeah, so one puzzle, it's related to Ramanujan's life, and yesterday was Ramanujan's death anniversary. So let's do something related to Ramanujan's life. So this is the actual story. Ramanujan and Mahalanobis. Mahalanobis was great statistician who founded ISI at Calcutta, and both were friends, and they were both in UK, in Cambridge at one and the same time. So around 1915, 1918. So Ramanujan and Mahalanobis both were friends. So he was a great statistician. And Ramanujan was very much friendly with many people, many Indians, and he had a habit of calling his friends for lunch and dinner. He used to prepare himself some South Indian curry, sambar, rice, pickle, papad, etc. So Ramanujan once called Mahalanobis for lunch, and Mahalanobis just came to Ramanujan's home place, and Ramanujan was cutting some vegetables. So Mahalanobis said, today itself I read one nice puzzle, interesting puzzle. Shall I tell you? And Ramanujan, while cutting vegetables, said, okay, tell me the puzzle. And once Mahalanobis told the puzzle, within seconds Ramanujan told the answer. So the puzzle was following. Write it shortly. A military officer stays, so there are houses numbered 1, 2, 3, 4 up to some number n, and one person, military officer, stays in some house number such that the sum of house numbers before that military person equals the sum of house numbers after the military person. So this sum and this sum are equal. And if the house number is at least 50 and at most 500, find the house number of that military officer as well as total number of houses. Shall I say once again?
Yes, yes, please.
Yes, sir.
So there are house numbers, or there are houses in a straight line numbered 1, 2, 3, 4, and so on. A military officer was living in one of the rooms, let's say call it small n, and total room numbers were capital N, and the military person house number n was such that sum of earlier numbers was equal to sum of further numbers, and n was at least 50 and at most 500. What should be small n and capital N? Is the puzzle clear? Or let me give smaller example. I'm not giving the answer for the puzzle. So I'm giving different. So for example, if there are 8 houses, say 1, 2, 3, 4, 5, 6, 7, 8, and our military person stays in house number 6, which is not valid because Mahalanobis put condition n is at least 50 and at most 500. So suppose our military person stays in house number 6, sum of earlier houses equals sum of further houses. Is it clear? So Ramanujan found it in within a second while cutting vegetables itself. Okay, and in fact, Mahalanobis took about 10 minutes to solve it. So you can see the greatness of Ramanujan while doing some other work. So he had no pen pencil there. While cutting vegetables, while cooking, he just listened to that puzzle, and within seconds he said, "Okay, take down your answer," and told the correct answer. Yeah. So with that, we'll stop for today. Tomorrow I'll continue with GP, geometric progression. Tomorrow will be our last session for this workshop, and I hope you are enjoying.
Yes, I enjoyed a lot. Thank you, sir. Bye, sir.
So
Thank you, sir. Bye. Bye, sir. Thank you, sir.
Bye, sir.
bye for today. So
Bye.
tomorrow we'll do GP,
Thank you,
geometric
sir.
progression.
Bye, sir.
Thank you, sir. Bye, sir.
Thank you, sir. Bye.